Hello algebra students. So in this video we are going to go through solving quadratic equations. So as you saw in the lesson, if you are given a problem where you have a product of factors and they equal 0, we're just going to apply that zero product property right away. Again, the zero product property says that if we're multiplying factors and getting out a 0, one of those two factors must be equivalent to 0. So either k plus 1 would equal a 0, that's your first possible case, or k minus 5 equals a 0. One of those two must equal 0 for the product to equal 0. So when you solve these two equations, you get your two answers. So subtract 1 from both sides of the equation, you get k equals -1, or add 5 to both sides of the equation, you get k equals 5. Again, write your answers in set notation in numerical order, so -1, 5, those are your two possibilities, -1 or 5. Going on to number 3, we're going to do the same thing because again we have the product of two factors and the result is 0. So we have 4k plus 5 could equal 0, or k plus 1 could equal 0. Solve the two equations to get your two solutions. So subtract off 5 from both sides of the equation, you get 4k equals -5. Divide both sides of the equation by 4, you get k equals -5/4, and simplify to -1 and 1/4. And I know some of you are thinking, but I wrote -1.25. Yes, that's fine too. So either as a mixed number or as a decimal. Please don't leave it as -5/4 though, because your numerator is larger than your denominator. So at least simplify a little bit and write it either as -1 and 1/4 or -1.25. On this one, we're going to subtract 1 from both sides of the equation and get k equals -1, so that was easy. All right, numerical order. This one is farther from 0, so it should go first, -1 and 1/4. It is less than the other one, -1. So those are your two solutions. All right, number 5. On this one, it's different. We don't have factored form already. Numbers 1 and 3 were given to us in factored form. This one we have to factor it ourselves to make it look like this so that we can apply the zero product property. So the first things first, we need to get all of the values on one side of this equal sign because again, we need it equal to 0 to apply the zero product property. So I'm going to add 5 to both sides, get x squared minus 11x plus 24 equals 0. And now that it's all on one side, now that it's a trinomial, I'm going to try to factor it. So I don't have a greatest common factor here, so I don't have to worry about that. And again, trinomials are factorable if they can be written as the product of binomials. So this one should be written as the product of two binomials. In my first two positions, I have an x and an x because when I FOIL these together, again, FOIL means, it's the acronym to help you remember how to multiply binomials. It means first, outside, inside, last. So first, outside, inside, last. FOIL. So when you multiply two binomials together, you have two terms in each. You're going to multiply the first two together, the outside two together, the inside two together, and the last two together. Again, you're really just distributing each one of the terms into the other binomial, but that's an easy way to remember how to do it, FOIL. All right, so the last two have to multiply to give me a 24. So I have different options. Look at the middle term though, it's a -11x. So the last two have to multiply to to a positive 24, but then add to a -11x once I FOIL the outside and the inside terms together. So I'm thinking I need a -8 and a -3. So let's just double check that. Multiply the first two, you get the x squared. The outside 2 is -3x, the inside 2 is -8x. A -3x minus 8x is -11x, and -8 times -3 is positive 24, so that is the factored form of that trinomial. And now it looks just like numbers 1 and 3. So now we can apply that zero product property. One of these two factors must equal 0 if their product is 0. So either x minus 8 equals 0, or x minus 3 equals 0. And some students typically ask me in questions like this, do I really need to show this step? For now, I'm going to say yes. Once you get up into Algebra 2, I'll probably say no, but I want to make sure that you don't write down that x is -8 and -3, or -3, because you ultimately have to set it equal to 0 and add 8 to the other side, and x equals a positive 8, or add 3 to the other side, x equals positive 3. So please show that work for now. Eventually I'll let you drop that out, but for now show it. So numerical order, 3 or 8 are my solutions. We're going to go through the same thing on 7, 9, 11, 13, you're going to have to add 2 terms over. 15 is the same, 17 the same, 19 is a little bit different, and then 21 is the same. So a lot of these are very similar to number 5. All right, so number 7, add 2 to both sides. We get n squared minus 10n plus 24 equals 0. Don't forget about that equals 0. We are solving an equation. This is not an expression. There's an equal sign. So it's an equation we have to solve. All right, factor the left-hand side. So what multiplies 24? Let's think 12 and 2. 12 and 2, I'm going to have to get a negative 10n, so this is going to be a plus 2. So n squared plus 2n minus 12n, that's that negative 10n. And then minus, oh, this will give me a minus 24. Oh, I need a plus 24. That cannot be correct. Let's get rid of that. Sorry about that, I missed my plus 24. So what does this factor into? Let's try a different combination. So the first two must be n, because n times n is n squared. The last two must multiply to 24. So let's think of some possibilities. We have 12 and 2, 8 and 3, 8 and 3 would not work. Of course, negative 3 and negative 8 should be... So this factors into two binomials. N and n have to go in the first positions because n times n is n squared, and the last two positions have to multiply to a positive 24, but then we've got a negative in the middle here, so that tells me I'm going to need two negatives, because a negative times a negative gives me a positive, but then I need to get a negative when I combine them. When I multiply the outside and the inside terms together and then combine them, I need a negative 10n. So let's go with a negative 8 and a negative 3. That'll be n squared minus 3n minus 8n. Oh, that would give me a negative 11n, so that is not good. That combination does not work. So let's try a different one. So in this one, it should be a 4 and a 6. So we get n squared minus 6n minus 4n. That would give me the negative 10n plus 24 equals 0. All right, so now the zero product property. One of the two factors must equal 0, since their product is 0. When you solve these equations, we get n equals 4 or n equals 6. n equals 6. So my answers are 4 or 6. All right, going on to number 9. The first step on this one is to get it equal to 0, so I'm going to subtract 6 from both sides of the equation and get minus 24 equals 0. Now, I'm looking at this one and I see right away that I have every number divisible by 2 at least, so I know I have a greatest common factor in this one. So the first step is to take out the greatest common factor. So you might think 2. What else is the smallest coefficient? In this case, the smallest coefficient is 6. What else is 6 divisible by other than 2? It's also divisible by 3. Is 18 divisible by 3? Yeah. Is 24 divisible by 3? Yeah. So it could be a 3. That's the greatest common factor. It's definitely not a 2 anymore because 3 is larger. So far I'm thinking the greatest common factor is a 3. But 6 is also divisible by 6. Is 18 divisible by 6? Yes. Is 24 divisible by 6? Yeah. So it's actually a 6 that's the greatest common factor. So we're going to factor out a 6. And then what would have to remain is an n squared, since 6 times n squared is 6n squared, minus 3n, since 6 times negative 3n is negative 18n, and a minus 4, since 6 times negative 4 is negative 24, and that still equals 0. So on this one, we're going to carry down this 6 in my work here, and then I need to factor this trinomial. So it's like we're ignoring the 6 for a little while and then factoring the trinomial. So the first two must be n's, because n times n is n squared. The last two have to multiply to negative 4, and I see a negative 3 in the middle here, negative 3n. So I'm thinking I need a negative 4 and a positive 1. Negative 4 and a positive 1 multiply to a negative 4. And then just to double check, the outside gives me a positive n, the inside a negative 4n, and those combine a negative 3n. So yes, this is the factored form. So now this one for the zero product property, I did one just like this in the notes. If you have the product of three factors and it equals 0, well then one of the three factors must equal 0. But 6 will never equal 0. 6 cannot equal 0. 6 will always equal 6. So this one I don't have to consider when I'm thinking of my possible cases of factors that could equal 0. Either this factor equals 0 or n plus 1 equals 0. There's no way to make 6 equal 0. So solve these two equations. We get n equals 4 by adding 4 to the other side, or n equals negative 1 by subtracting 1 from both sides of the equation. So my two answers on this one, negative 1 or 4. Going on to number 11 on the back side of this worksheet. On number 11, we again have to start by getting everything to one side, so I'm going to add 15 to both sides of the equation. Get n squared plus 8n plus 15 equals 0. Now that it's equal to 0, I can go ahead and factor and then solve by using the zero product property. Alright, so what does this factor into? I already know this one off the top of my head because I'm thinking of the values that multiply to 15, 3, and 5, and then I know if I have 5n plus 3n, that gives me 8n, so right away I can just factor that one. So n plus 3 must equal 0, or n plus 5 must equal 0. So n is equal to negative 3 if you subtract 3 on both sides of that equation, or n equals negative 5 if you subtract 5 on both sides of that equation. So numerical order, negative 5, negative 3 are my solutions. All right, number 13. For number 13, again, get everything to one side. So I need to add 5k to both sides, 5k squared to both sides of the equation. 5k squared will combine with its other like term, negative 4k squared. So 5k squared, add it over here, 5k squared minus 4k squared gives me 1k squared. I still have minus 8k. And then for this one, I'm going to have to add 3 to both sides, and both of those negative 3's will cancel out, so that's all I've got. That equals 0. So this one's a little bit different. So on this one, do I have a greatest common factor? You always have to look for that greatest common factor right away. And in fact, yes, I do. They both contain a k. They are both divisible by k. So I'm going to factor out k. So what has to go in the first spot? Well, k times k gives me k squared. What has to go in the second spot? Negative 8, because k times negative 8 is negative 8k. Again, you have to be able to distribute this and get back to what you started with. And that still equals 0. Well, this one, it didn't require us to factor a trinomial, we just factored a binomial. And that's what we did in one of the very early sections of this chapter. So either k equals 0 or k minus 8 equals 0. So these are your factors, k and k minus 8. So we've already done the work. There's no work to be done. K equals 0 is one of your solutions. The other one, you have to add 8 to both sides, and you get k equals 8. So there are your two solutions, 0 or 8. All right, go on to number 15. We're going to go ahead and subtract 5 from both sides, so we get 3r squared minus 16r. Subtract 5, we get a negative 12. And now that we subtracted off that 5, we have equals 0. All right, so then we have a trinomial. Is their greatest common factor? So 3 is a prime number. Are the other numbers divisible by 3? Well, 12 is divisible by 3, but 16 is not. 15 is, 16 is not. So we don't have a greatest common factor. So this one we have to go right into factoring. So I have to get a 3r squared, so a 3r and an r are my first two terms. And now I have to think of two values that would multiply to a negative 12. So I'm thinking negative 4 and 3 or negative 6 and 2. Negative 6 and 2. Just double check here. The outside terms would multiply to a negative 18r, the inside a 2r. If you combine those, you get that negative 16r. And like I said, the more you practice these, the easier they will get. You might have had to try a whole bunch of different combinations there, and I can just kind of think of them usually. So just keep practicing. You'll get there. All right, so one of these factors must equal 0 for the product to equal 0. So either 3r plus 2 equals 0, or r minus 6 is 0. Solve these two equations, so subtract off the 2 and divide off the 3. R is negative 2/3. On the other one, if you add 6 to both sides, you get r equals 6. So there are your two solutions, negative 2/3 or 6. All right, going on to 17, three more to go. Number 17, on this one, you need to subtract 3 from both sides, and just like what happened on number 13, when you subtract 3 from both sides, it will cancel out the 3 on both of the sides. So we get 7k squared minus 6k equals 0. So factor out your greatest common factor, which again is just k. What's left is 7k minus 6, because again, k times 7k is 7k squared. We have a minus, and then k times 6 is 6k, and that equals 0. So one of these two factors must equal 0. Either k equals 0, or 7k minus 6 is 0. So then here we add 6 to both sides, divide by 7 on both sides of the equation, we get 6/7. So those are your two solutions, 0 or 6/7. All right, the last two. This one's already a binomial, so we're just going to start by taking out our greatest common factor, or factoring out our greatest common factor. And what remains is a 7x plus 2, and that equals 0. Because again, x times 7x is 7x squared, x times 2 is 2x. Set each of these factors equal to 0. And solve. This one's already solved, so we go to this one, subtract off the 2 from both sides, divide the 7 on both sides, and we get negative 2/7. So my two answers in numerical order, negative 2/7 or 0. And for the last one, add 59x to both sides. So I have 8x squared. Since I'm adding it over here, it's going to be a positive 59x plus 21 equals 0. So on this one, we have much larger numbers than on any of the other problems. Again, you want to look for a greatest common factor right away. So is there a greatest common factor? Well, 8's the smallest number. 8's divisible by 2, 4, or 8. So let me just start with the largest one. Why not? Let's go with 8. Is 21 divisible by 8? No. So let's go to 4. Is 21 divisible by 4? No. And then is 21 divisible by 2? No. So there is no greatest common factor. All three of the terms would have to be divisible by one of the factors of 8, either 2, 4, or 8. And I just looked at 21, and it is not divisible by any of those numbers, so I know I don't have a greatest common factor. So I need to go right into factoring this trinomial. Okay, I have an 8x squared, so the first two terms need to multiply to an 8x squared, and there are multiple possibilities there. The last two terms have to multiply to a 21, and again, there are some possibilities there. So this one might take a little while. It's not as obvious as the other questions, in my opinion. So let's try some possibilities. How about a 4x and a 2x? Let's try to exhaust those possibilities first. So then I need two numbers that multiply to 21. I'm going to have to get 59x. Now that's a lot of x's. So I'm going to try to put the largest number over here. But if I put, let's say if I put a 21 over here, I'm already going to have 84x, and then I'd be adding on more x's. So that's not good. So I'm not going to put that over here. But how about a 7 and 3, 7, 14, 21, 28, and 6? No, that's not big enough. So I'm not seeing any possibilities with this combination that will work. So I'm going to try an 8x in my first position there, and an x in my first position there. So now let's see if I have a 21 and 1. That's not going to work, but a 7, 56, and 3. Yes, there it is, a 7 and 3. And since I have all plus signs in here, I need plus signs down here. All right, so 3 and 7 multiply to 21. 8x and x multiply to 8x squared. But just to double check this, I'll show you my work on this last one. I'm double checking I've been double checking all of these as I factored. And I've been saying it verbally. So these two multiply to 8x squared. That's my first term. The outside and the inside, I get 7 times 8x, which is 56x. The inside gives me a 3x, so I need to combine those like terms in a minute. And the last two multiply to that 21. That was the constant on the end here. So combine those two middle terms, and I kept saying this verbally. I'd say, okay, 56x plus 3x is 59x. So the plus 21, the 59x, that's what I wanted to get. So that's why I knew that this was the correct combination of values. All right, so now we can apply that zero product property. Either 8x plus 3 equals 0, or x plus 7 equals 0. So 8x equals negative 3. By subtracting 3 from both sides, divide up the 8, you get x equals negative 3/8. Or subtract the 7 from both sides, x equals negative 7. So my two answers are negative 7 or negative 3/8. And that is it.